We are so thankful you have chosen to spend some of your time with us to continue learning from the collective knowledge of our NYU community. Today's guest lecturer is Dr. Cassandra Thiel, an assistant professor at New York University in the Grossman School of Medicine, the Wagner School of Public Service, and the Tandon School of Engineering. Dr. Thiel, I'll pass it over to you.
That's great. Thank you so much. All right, so I'm going to share my screen and get this presentation set up. Yeah, so my background is actually in civil engineering, and I ended up kind of in a different realm of research from what usually happens. But during grad school, I was learning about life cycle assessment and sustainability. Life cycle assessment is kind of how we quantify emissions from a product or process. And while in grad school, I met a surgeon who was very upset about how much garbage she could make in her surgeries. And she wanted to know what she could do differently to minimize her footprint. And life cycle assessment, it turns out, is a decent tool to make that kind of call. And so through the work with her, I kind of got hooked onto this topic. So to kind of give you a little bit of background on why we'd want to look at sustainability in healthcare. First off, of course, climate change is impacting human health in a lot of different ways. We're seeing this through hurricanes and fires, just more intense storms. There's disease factors and extreme heat. All of these things are, of course, impacting individuals' health. But more than just actual health impacts of climate change, medical facilities are struggling to keep up with the impacts of climate change. So here's from an image from the campfires in California a few years ago now, where 3 hospitals were forced to close. One of them will not reopen. This is a picture of NYU Langone, where Hurricane Sandy forced us to close the hospital for 3 months. We weren't sure we were going to reopen, but a hospital without power is pretty devastating, right? We had no elevators, no ventilators, no lights, no ventilation in general, right? All of that stuff got shut down. So climate change is really impacting our ability to provide care. Here's just a few images of the other damage that was done during Hurricane Sandy at the medical center. A lot of flooding, of course. And if it's not directly impacting care, then it's impacting our supply chains. So Hurricane Maria hit Puerto Rico, which is a major manufacturer of a lot of pharmaceuticals. And so there were shortages of things like IV bags, which are crucial to providing healthcare. And these kinds of shortages are likely to continue. But all of that's climate change's impact on healthcare. It turns out that healthcare has a pretty substantial impact on climate change. We use a lot of resources to provide healthcare. So recently, we've been kind of taking stock of national healthcare services and their impact on the environment. And you can see that in the UK and Canada, their healthcare systems are about 5% of their carbon emissions. Australia's healthcare system is about 7% of theirs. And America, we're actually around the 9 to 10% mark in terms of how much of our carbon emissions are coming from the healthcare sector. Basically, if the US healthcare were a country, it'd be the 13th largest emitter in the world, ahead of the entire UK and all those other countries. So we have a pretty sizable impact. It's been growing over time, kind of as healthcare rises in the share of GDP. We're consuming more resources for healthcare. And this is a really fun grid, which is to say that climate change isn't the only impact that healthcare is having adversely on human health. There's also things like particulate matter, that's PM, like the third row down. And all of these things can be quantified into the loss of life. So the column on the far right is disability adjusted life years. Just the particulate matter, the air pollution from healthcare, from the healthcare sector, results in the loss of 435,000 lives annually, years of life each year. So it's not direct one for one, of course. These are talking about the supply chain and the disposal. So those emissions are kind of scattered throughout the world, but this is having an impact on people's health. One of the most tangible examples of this is actually for the Sterigenics facility in the Chicago area, which was closed down, forced closed 2 years ago. Essentially, this plant and a few others like it in the region are sterilizing, or were sterilizing, surgical instruments using a chemical called ethylene oxide. Ethylene oxide is very toxic. That's why we use it to sterilize single-use surgical instruments. And basically this facility had been leaking a little bit of ethylene oxide, but it was still within their EPA limits. And what they had found was that the residents in that region were having higher rates of cancer than the rest of the Chicago area. And it was most likely a result of this ethylene oxide release. So community outrage, I should say, forced this plant to close. But the sad fact is that there were many people who were diagnosed with cancer and they were being treated with supplies that would have been treated with the ethylene oxide that gave them cancer in the first place. So this is the sad cycle of healthcare that we're working to change. So for those of you who are not familiar with healthcare, I just want to kind of run through what we're talking about when we're looking at these types of emissions. This is an inpatient unit. That's what a lot of people think about with healthcare. There's certainly a lot of resources used here, right? People live in the hospital, so they need food and everything associated with a home, in addition to all those care aspects, supplies and energy. There's, of course, surgeries. These are probably the most energy and resource intensive areas of a hospital, and this is where I tend to focus a lot of my research. Everything blue here, outside of that little instrument on the left, but everything in blue is going to be thrown out at the end of the surgery. There's a lot of waste in these areas. We use a lot of single-use supplies. All those supplies have to come from somewhere. And so we have storage facilities in the hospitals, typically in the basements, where all these supplies come in and are kind of sent out to other areas in the hospital. There are reusable supplies in a lot of these clinical areas, especially surgery with stainless steel instruments, and those have to be cleaned somewhere. And it turns out there's a room also, again, usually in the basement of a hospital, called central sterile, where they're cleaning all these supplies, and that takes a lot of energy and a lot of water. There's, of course, a lot of garbage coming out of a hospital. So here you can see on the left chemical wastes from our labs being transported out by waste haulers. And on the right is hazardous waste. So this would probably be bloody or infectious in some way, waiting to be taken out. This is kind of daily. There's a lot of garbage generated in a hospital. I think NYU Langone Health's main campus generates something like 18 tons a day. So there's a lot of garbage coming out of medical facilities. We rent linens typically in most hospitals, and those linens have to be cleaned and processed and shipped back too. And then, of course, if you're moving further upstream, all that stuff has to be manufactured. This is a different medical device plant in the Chicago area where they're wrapping up these single-use surgical kits called custom packs. So each hospital orders their own for a specific type of surgery, if it's eye surgery or heart surgery. And this factory, they wrap up all those instruments specific to the hospital and they sterilize them with ethylene oxide and then ship them off to the hospitals. And they're collecting supplies from all around the world, or they're purchasing their supplies from all around the world. Of course, the garbage just doesn't leave the door, it has to go somewhere. So this is a waste treatment facility actually in India. Here they're incinerating hazardous waste. So it tends to be, the bloodied infectious stuff or sharps. Basically, you can see where the healthcare system is kind of this huge thing, and we have a lot of inputs and outputs to this huge thing. A hospital can actually kind of be thought about as a city in and of itself, right? We have energy demand. We need to have our own backup generators and power supply in case of our links to the city being shut down. We have all those healthcare clinical activities that are occurring, but we also have kind of like the normal day-to-day things you find in even a home, right? Like we have to prepare food. We have to have transportation to and from the site. There's a lot of things happening in a hospital, which makes them really fascinating to study. And of course, really great opportunities to work on sustainability and to be an example for the community on what sustainability can be like. The bulk of the research in my lab is really focused on mitigation. So we're really trying to quantify that environmental footprint and figure out ways to change it. And some of my first work that I first talked about, her name is actually Noe Copley-Woods, and she's at University of Pittsburgh Medical Center, which is where I had gone to grad school. So we started out looking at hysterectomies. So this is surgery where you remove a woman's uterus, and there's 4 different rough ways to do it. And we actually just looked at all of the resources needed to provide those surgeries. So here we're actually digging through the trash and sorting it out by what kinds of materials are there, what kinds of materials were used. So this is the garbage from one hysterectomy. Same here, garbage from one hysterectomy. And waste audits are a fantastic way to really understand a system. And this is true if it's your own home or your business or a surgery. You get to really understand what was in there, what was used or not used, and just kind of the total volume of waste. So some of the things that we were discovering while we were in there, sorry that one picture got twisted, we found unused supplies, which are not kind of mentioned here, but there's a lot of things that get thrown away without being used because of the nature of operating rooms. We found stainless steel instruments that are disposable. So they're made with a lower grade stainless steel, and whether or not they're used, they're in those custom packs and they have to be thrown out. That's kind of that middle element here. On the left, those are laparoscopic devices, cautery guns and things. They're electronic and they're also single use and disposable. And then on the right, tilted on its side is a robot. So the robot has these things that attach to its arms. So this is a robot that actually sits over the top of the patient and does the surgery while the physician is at a console across the room. It's really cool. But the attachments to the robot are, of course, very electronic, but only semi-reusable. They can only be reused, I think, up to 20 cases. And it's very expensive to purchase this stuff. And of course, it's just very wasteful. And so when we were digging through this waste, we found, of course, batteries, just AA batteries, probably 6 to 8 of them in the laparoscopic and robotic cases. The nurses we were working with actually knew the batteries were in some of this stuff and they were trying to save them, but they didn't have enough pagers to put the batteries in. Like, there's just so many batteries coming out of this operating room. We found reusable supplies that weren't supposed to be thrown away that accidentally were, as they wrapped up in these big drapes. And as I mentioned, these unused, unopened items. So this is a urinary drainage bag that's in its own sterile packaging, but because the overarching packaging had been opened, it also needs to be thrown away. And that kind of waste is very prevalent in surgeries. This is not my study, but a study done out of California where they looked at neurological procedures and just all the items that would be thrown away after their surgeries. And they found it was about 13% of their supply costs were these supplies that they're not using, but are throwing away. And if they could somehow stop throwing those things away, they would probably save about $3 million a year in this one department in one hospital. So surgeries have a lot of opportunity for improvement. This is what a life cycle assessment kind of looks like. So with life cycle assessment, we're taking all those different inputs, right? The supplies and the energy and all of that stuff. And we're matching it to databases that tell us how much is emitted in producing those items. And then we're able to generate this really nice large graph. Assuming you're all more on the engineering mindset, this won't be so overwhelming for you. Healthcare providers kind of hate this graph, but that's okay. So to kind of break it down, we've done the life cycle assessment looking at a bunch of different emissions categories, not just carbon footprint or greenhouse gases. And we've done them for all 4 types of surgeries that we were looking at. So the groupings of 4 are those types of surgeries. We have abdominal, vaginal, laparoscopic, and robotic. And then each grouping is a different type of emission. So the first one's ozone depletion. Then we have greenhouse gases, smog, acidification, eutrophication, carcinogens and non-carcinogens. Those are human health impacts. Respiratory impacts, particulate matter. Then we have ecotoxicity and cumulative energy demand, for those of you who are curious about this. Now, the subcategories have been kind of written over, so it's not so crazy a graph, but you can see that green color is kind of dominating all of these different categories, and that's just the production of those single-use materials. So it's not even the disposal, but just the production of those things. And that's important because our surgeon and a lot of the clinicians that I talk to, the advice is usually to recycle more. Everyone's very focused on the downstream aspects, that we generate so much waste. What can we do to prevent that waste? And what our life cycle assessment was showing us is that your downstream impacts are very minimal. If you have proper waste treatment, there's not that much that gets out into the environment when compared to just the production impacts, right? Shipping all the raw materials, manufacturing them into products, shipping them, ethylene oxiding them, and whatever else. all of that has a much larger footprint than anything you can do downstream. So perhaps a lot of the initiatives to change this should focus on that upstream component. And the other thing you'll notice too is that the laparoscopic and robotic cases tend to have much higher footprints, and that's because of those electronic pieces that are single-use and disposable. They're higher tech, and as a result, they unfortunately generate a lot more waste that's a little bit more intensive, and they, of course, use single-use supplies that are a little more intensive to manufacture. So there's definitely a lot of takeaways from this. After the hysterectomy, I actually went to look at cataract surgeries, which are very prevalent surgery. It's actually like 12% of Medicare's budget is just for cataract surgeries. So we spend a lot of money on cataracts, and there's one facility in India that's actually incredibly efficient. It's called Aravind Eye Care System, and I'd gone there to measure their carbon footprint. And for the same surgery in the UK, they're emitting about 5% of what the UK is. And their outcomes are actually better than in the US. So clinically, they're doing just fine, but they're reusing just about everything in their surgeries in a safe and effective way. So this was interesting just to get a different feel, right? Something that was not so focused on single-use supplies like we are in the US. My lab has been working on a variety of these types of assessments in a lot of different specialty areas. So another one we had looked at was interventional radiology. This is where they're using machines like CT scanners and PET scanners and things like that to help with placing ports in people's bodies. So it's a combination of radiology and surgery, essentially. Is my naive way of framing this. So I had students who went in for a week and collected data on our interventional radiology suite. And this is kind of what we're finding. The production of single-use supplies dominates the emissions. This is just greenhouse gases. But energy is also a pretty important concern. So here with the heating, ventilation, air conditioning system, that's the HVAC, the dark blue is the time spent in surgery, and that hashed bar is the time the HVAC system was running, but no one was in surgery, so weekends and off hours. And you can see that that represents another form of waste in healthcare systems. These operating rooms are typically running 24/7 as if they were having surgeries. But a lot of our operating rooms are scheduled surgeries. You don't need them for emergencies, and it doesn't take long to get the HVAC systems up to their high turnover rates and the right temperature settings. If we were to relax those settings, reducing our turnovers from 15 to 20 air changes an hour to something more like you'd find in a standard office, you would actually save quite a bit of energy, and the operating room would still be fine. So those are the little things that we're just not doing well in healthcare. We started looking at inpatient units, of course, too, moving away from surgeries a little bit more. This has got a lot of colors, but the left side of the graph is for more low intensity care, so your typical inpatient unit, and the right side is a high intensity care, intensive care unit. And there's different allocations that we were using to account for energy, which is not typically metered. So we had to make some estimates, and that's why there's the floor area and the staff. Those are the allocation types. And then the third bar on each of those for the UK is the United Kingdom is actually doing very well on auditing their greenhouse gases from their health services, in part because they're actually legally mandated to meet their Paris Climate Accord carbon reductions. And as a national health system, that's part of the targets. So those values came from the UK. We were using the same approach to carbon footprint modeling. So you can see we appear to have a higher footprint in our inpatient units when compared to the UK. And there's probably a lot of reasons for that. But anyway, we've also done some work in pathology labs. So we do these types of lab assessments, like taking samples of human tissue and testing them, are done a lot in the US. And though the footprint is pretty small, it's here you can see it's probably less than 1 kilo of CO2 per biopsy. That adds up over time given the volume of healthcare services. My lab has also actually done other things outside of the clinical care, though we tend to focus on clinical care. And this was one kind of fun fun waste audit that we had done. I really enjoy waste audits. We actually went through the kitchens at NYU Langone to look at composting potential, right? So there's a lot of organic material that's coming out. It doesn't need to go into a landfill. There's a lot of other better endpoints for it that could be better for carbon emissions and more like circular economy, trying to use that as a valuable resource rather than landfilling it. So we actually went in and audited for a day all of the waste coming out of our hospital kitchen, and it was pretty substantial. And then we looked at how we might reduce the carbon emissions by composting and what composting could potentially be like, where we have an ideal scenario that's probably not going to happen, but then a more likely scenario given the space constraints and the staffing situation. And really our goal is to use this research to make data-informed decisions in medical care, that we all have limited resources, both in time and money, and implementing sustainability can save a hospital money, but there's of course trade-offs, and you have to make sure that you're doing the right thing. We want to prevent what's called greenwashing, which is where we say we're doing something sustainable and then it ends up actually being worse for the environment. And so this was taking some of that hysterectomy data and really looking at what we could change. And what you'll notice is that using minimal instruments, right? So if we could reduce what we're bringing into the surgery to some set small amount, we would reduce our carbon footprint by almost half. Reprocessing single-use devices right underneath that is a form of reuse, and that would save us maybe 10% of our carbon emissions. Anesthesia is a third reduction, and there's I won't go into that too much, but basically anesthetic gases are greenhouse gases, and there's certain ones you could pick that would have lower carbon emissions profile, but would be just as effective clinically. And if you go way over onto the right, that maximize recycling, if we recycled absolutely everything we could out of this operating room, we would save 1% on our carbon emissions. So it's really a shame that a lot of hospitals are focused solely on recycling as the solution for sustainability. It really doesn't change your emissions as much as reduction of supplies and reuse of supplies where you can. So those are some of the major takeaways. We're obviously building on a lot of this. I've been working a lot with cataract care providers. Globally, there's a lot of interest, and especially in the US, there's a lot of interest in changing the way we're doing cataract care because it can be done much more efficiently. We know this from the Aravind example and other low resource settings. So here we've developed a tool that enables eye care providers to actually quantify their carbon footprint. And this will actually also allow them to measure their productivity, so how many cases they can see in a certain time period, and also looking at their costs. So that's all on the mitigation side. Of course, we have to adapt to climate change. It's coming, and the question will be, how intense will it be? But we're already seeing these disruptions, and so we have to think about how we're going to be more resilient. And with COVID, my work also kind of took a turn into more supply chain issues. So of course we had huge PPE disruptions, personal protective equipment. This is a picture of NYU Langone where those paper bags are assigned to an individual person who's on staff, and that's where they keep their N95 respirator between shifts. This was during the peak of the pandemic when we were running pretty low on supplies. So they were required to hang on to those things. Basically, we had factory closures, and there was disruption in the import of raw materials. A lot of these things were being manufactured, of course, in China. And then the demand skyrocketed. And the result was that not only was it just difficult to find things, but we were also kind of, the costs were exorbitant to try to do something about this. And so I was awarded an NSF Rapid grant with a colleague, Camille Gabati at Johns Hopkins, and we've been analyzing the data from hospitals to see the differences in purchasing patterns of PPE between 2019 and 2020. So for shields, here you can see the solid line is 2019, it's nice and steady. We were making regular small purchases throughout time. And then in 2020, all of a sudden we have this exponential growth in March where COVID was really looking terrible. We knew the supplies were going to be hard to find. And you can see the change in total purchasing, where in 2019 we purchased 50,000 shields, and in 2020 it was 1.4 million. That is a huge change in our purchasing patterns, and I'm not sure that any supply chain could really keep up with that. And similar kind of findings with masks. We have a few other PPE categories that we've been looking at, and we're trying to figure out ways that the health system can be more resilient and can keep better track of their supplies. PPE was definitely not something that people cared about until, I mean, they cared about it, but they didn't keep track of any of these supplies until COVID hit. I could probably walk into any operating room and steal a bunch of gloves and masks and no one would have cared. And then all of a sudden we had some pretty stringent policies that were enacted around PPE, which would have been ridiculous to anyone a few years ago. All right, so we're limiting access to PPE, limiting people's, going into these spaces where they'd need PPE, punishing personal use. Some of these are interesting. We're looking for ways to reuse or multi-use disposable PPE, right? Reprocessing N95s had kind of come up. Using reusable isolation gowns is another kind of issue. And this has got all of us in the sustainability world wondering if these are policies that we can just keep, that they don't necessarily have to be just for a time of crisis. So the big takeaway for anything with sustainability and resilience is that healthcare is a huge giant system and there's so much that needs to be considered, and so much that we can improve. There's a lot of opportunity here, and a lot of things to influence. So we're working on it in our lab. I welcome any questions you have. That's kind of a high level overview of all the things sustainability and healthcare space. If you do have questions and we run out of time, please feel free to email me. Thank you very much. How do life cycle assessments work? Yeah, I didn't have a good slide for that, unfortunately. Sorry about that. But basically what we do is, so you think of a life cycle as, here I can stop my screen share. Product life cycles are very linear, as you can imagine, where we are extracting raw materials and then we'll ship them to where we're manufacturing them, and then we use them and then we throw them away. And each of those stages has inputs, energy, materials, water, I don't know, all those things, and they all have outputs. So there's always emissions, there's waste, there's carbon dioxide, there's all those other emissions categories that I mentioned. What life cycle assessment does is it sums up all those emissions and condenses them across the life cycle into a single value. So the way that we do them is to really understand our system. There's ISO guidelines on this, but we try to set boundaries around what it is we're looking at. So if it's a hysterectomy, we drew the lines around the operating room. We didn't go too far upstream or downstream. And we looked at all of the energy and supplies. We matched those to databases that exist in life cycle assessment software. So it'd be like 1 kilo of plastic mapped to the kilo of plastic in this database. And the database will say, on average, manufacturing that kilo of plastic emits this much. And then through that analysis, there's some matrix math basically that will condense it down, convert it all into carbon dioxide equivalents for greenhouse gases. And that's where we get that single value. So that's the idea about a life cycle assessment. It's definitely a quantification tool. There is some art to it because of that mapping and the assumptions you have to make about your system. So it takes quite a bit to work. They can be long and intensive. You can do them, we're doing them more the process-based way, which is to say 1 kilo of plastic, but you can also do them via financial assessments. So how much money was spent, there's actually input-output models based on the US economy that we can model emissions that way. It looks like Jeanette Martinez, you have your hand up. Oh, here you go, okay. Oh, this is maybe a question for Alexandra. Where will the presentation be posted?
We'll have the presentation posted on the Tandon alumni website, and we'll also email all of the attendees today. If we don't have any more questions from the Q&A, I would like to thank Dr. Thiel for your presentation. This concludes our 3-part Lunch and Learn series. We thank you all for your participation, and we hope you have a wonderful day. Thank you.
Thanks so much, everyone.